Hello there YouTube. I'm just going to show you through a project that I've decided to do today, and I thought I'd walk myself through the steps on camera so that I've got a record of what I'm doing, and also it might be interesting for other people to see how I go about my process. My brother has asked me if I could take this type of mouse with a ball in it and add to it a normal optical mouse on the underside so that you could potentially move this mouse along as if it's a normal mouse, and then when you want very fine aim you could roll the ball, which I think actually sounds like a pretty good idea in theory if I can get it to work. My first thought was a mouse this big has got to have a lot of extra space in it, and as it turns out I'm not wrong. I looked up the teardown of this kind of mouse on iFixit, and you can see that the battery compartment hugely empty. There's loads of extra space to fit other parts in, and if all we want to fit in is another flat circuit board, that seems like it could possibly work. The other thing I thought of was this mouse uses a unifying receiver, so if I can get another Logitech mouse that also uses a unifying receiver, then all I have to do is put the circuit board into the bottom of the other mouse and pair them both to the same receiver. That way, whichever mouse you're using at the time, it should just switch seamlessly. So I found this mouse, which is A, fairly cheap, and B, if you look at the teardown, it looks extremely small. What I've done is I've found the two main product pages and the two iFixit teardown pages. So that's my first go-to. Now the first thing I need to do before I order anything is make sure that everything could fit in place. And the way I've done that is to download this picture and this picture and load them in to Google SketchUp. Then I've put measurement lines across them, and from the Logitech website I have taken the dimensions. So here we've got the exact dimensions of the mice, so you can scale the model to the dimensions. So it's roughly 145 mil, so I've scaled that dimension to 145 mil. So I know that this battery section that's empty is about 70 millimeters of space. I mean, granted, the height clearance at the back could be a worry, but I don't think it will be too bad considering the thickness of the battery it's currently using. And should I have problems fitting a AA in, I could always fit it with a AAA or even a differently shaped lithium-ion battery and charger, so that's probably not too much of a problem. So we know we've got about 70 millimeters of clearance, so let's find out how much the internals of the other unifying mouse take. So what I've done is I've done that for the other mouse I've found. This is a much easier shot to work with. As you can see, the last shot was from an angle, so that makes it much harder to tell whether the lines line up correctly, but this one is directly overhead. So I've scaled the whole photo to be the measured dimension. Measured dimension is 94.7, so that's the exact right height, and the whole circuit board, top to bottom, is just about 70.7 millimeters. So that's a little bit too much, but I could probably file 0.7 mil off either end and not even notice, let alone what I think I could do, which is I don't need the mouse buttons from both mice. I don't need the scroll wheel from one of the mice. So what I can do is make a cut along here where this slot is the sensor for the scroll wheel and the right mouse button, and probably a cut along here where we've got the sender for the mouse wheel and the other mouse button, and then just that segment there is only 54 mil. 54 should definitely fill in that space. Now the one problem we do have is that they both use a AA battery, which on this scale, let's find out how big it is. Line, drag it out. So the battery itself is going to take about 50 mil. So let's go back to this. We can probably fit it and still fit a battery possibly in here. Whether or not how easy it will be to actually change depends. We might also need to fit a lithium ion a flat pack and a recharger with a boost circuit or something, but we can probably manage that. So it does seem like there is enough space in the back of this mouse to be getting on with. So I think we've found the candidate and the add-on mice that we need. So the next thing to do is to order them. Right, so the mice have now arrived, and I've tested that they do work together and they both work with the same unifying remote. So now we just need to take them apart and see how they fit. I've also checked how much amperage they draw. The large trackball draws about 2 milliamps. This draws about 0.2 milliamps. So I honestly think that if you add 0.2 to the 2, this is already drawing I mean, I don't know why it's drawing so much more. They're roughly the same anyway, but I reckon if you add it together, one battery should be able to support both of them. So let's get started by taking apart what is essentially going to be the host. Let's take the battery door off. The unifying receiver is on the side already because I was using it to test, as with this one. I've already taken the unifying receiver out, but obviously not the battery. So the first thing we're going to have to consider is that these are rubber in order to stop it from sliding. We might either have to use these, or more than likely just buy some new ones. They're not terribly expensive to buy new grips, and you would want rather large ones for a mouse this large. You don't want ones that are rubbery if you're going to be sliding. Now to take it apart, most likely not only do we have that screw, so this one's probably not hiding anything, but we'll probably have screws under the other feet. That is usually the way that mice hide. Oh, come on you. Yep, there we go, there's one. Now something I like to do is choose an orientation for an object I'm taking apart. So for example, this way up, and then lay the screws out in the same order that they came from. Not because I expect them to be different sizes, but because each of these individual screws into plastic will usually have tapped its own hole. So if there is any variation in the screw at all, there is a chance that by you putting it back in the same hole, it will go in smoother. I mean, that may be me just being a bit strange, but I'll take any chance I can get to make any taking apart go smoother. Right, it's clearly free at the front, so let's check the back. Yeah, it's a bit tight here. Don't want to break any clips if possible. Luckily I've let my fingernails grow, so it's like the ultimate natural spludger. Just be sure not to hurt yourself in doing so. I actually need to get my smudges out. I can't feel... Oh, is that a screw post? There may be a screw post under the label. Now this might actually not be a screw post, it might be a programming header under here. Yeah, no, that is test points. So that means, luckily, I should just be able to continue spuddering it apart and not be about to break anything. Yes, there. Explains a lot. Now, we don't need this label. I've no intention of sending this back after I've modified it. It worked when it arrived, so anything that I do that damages it is up to me. Now, this screw won't be here once we're finished with the modifications anyway. Right, so that is the center screw. So that goes sort of there in my screw diagram. Right, now it should just come straight open. Yeah, that was a lot easier. Right, now I've got to be careful because I can see a ribbon cable and we don't want to break it. There we go. So this is a zero insertion force connector. This is a zero insertion force cable. That is going to be a right pain in the butt to put back, but luckily we don't have to yet. So what the plan is so far is in this zone here, where currently we have just the battery, you could roughly fit, I mean, not quite, but you could roughly fit the whole mouse of the other type. So if we can almost fit the entire plastic body of the mouse, we should be able to fit just some of the internals. My idea is to take this section here, or possibly this section, depending on how much of it needs, and transplant it into this section of the base here, and try and move the battery either across or diagonal in the way that this one is diagonal, and connect it to both. But I do think we need to see if they can both run off of one battery. Yep, there we go. And now we have, wow, look at the size of that board. It's tiny. I could literally just cut the battery off and shove a lithium ion cell in without even having to cut off the front as I had suggested. However, on the other hand, I still can. I'll probably narrow the board down as much as possible because I don't need the buttons, and these on-run switches will be useful for repairing other mice, so I'll desolder those. Right, so that is the course cuts done. Now we need to grab some files. I think I'll use my worst set to start with and clean up some of this mess. Just tidy up the edges where there's chunks of plastic that have essentially gathered up. And from my experience cutting thin plastic, it's easier to use a knife than it is to try and be precise with the Dremel. Shake this off into the bin. Oh, and not drop it into the bin like I just did. Let's see that we haven't ruined it so far. So that still fits down on there, and that still fits down on those. So the important connectors are still there. I just need to make sure that I haven't affected this post or the switch. I haven't affected this post, but anything behind that, except this post where the this sits, is fair game. So a trick surgeons do so they don't cut the wrong leg is to mark the bits that are coming off. I'll start by all the bits that will definitely be worth removing, and I can expand on those if, when I get to measuring, you know, in the second measure, I haven't got enough room. Right, so we want grip it, bend. We are going to need to shave off some of this end, even if it's just the tip, and then take off the on switch. Right, I'm going to go and get the soldering iron. Right, now as you can see, I've tidied up the desk a little bit, but the next stage is to take off these two buttons and this switch because I need the space. Don't know if you can see this tool here. It's a solder sucker that also has a heated end. It's only about 10 quid. I know a lot of the good YouTubers use something like a soldering gun with a vacuum pump, but that's expensive and I don't have the money. So instead of that, I'm going to... Actually, I know what I need to do. I don't need to add new solder, I need to add more flux. Now this is far too much flux, but it is what flux I have at the moment. If I can get my hands on a proper thing of flux, that would be a lot better. But the flux just allows the solder to flow better. Right, first we prime the top. That is the suction button. I've let it heat for a while. You can't tell, but when you touch a sponge, you can hear it. Although not very much. Oh. Let's have the fan on, shall we? Don't want to be breathing this crap. I'm going to need to put some fresh solder in there. I was hoping to avoid it. Or the soldering iron might not heated up yet. Oh no, there it is. No, it wasn't heated up enough. You really need to hold it on there to let the solder flow. And line up the holes correctly. But when you get it right, it's a lot easier. Try and make sure there's no solder left fouling the connection. Perfect. Now let's see if these are free. It just comes off. Where are my tweezers? Oh, there they are. So this side with this one isn't... Is it loose? Oh, it is loose. No, it's not. Just give it a bit more welly. It was stuck by the smallest margin. So I've just got some cotton buds, or Q-tips as the Americans call them. And this is the alcohol I was using earlier. Just absorb that and then clean the board, get all the flux off. And then get the pen out so that we know the safe region on this is so. That's the next thing to do, I suppose. Cut the board. Right, the best way to do this is probably not what I'm doing. Now, I can't go too close to that trace there, which you obviously can't see, but there's a trace there that is the antenna, and I shouldn't get too close to. Now I'm going to go clean it off outside. Alright, now that's done. I went outside, I used some canned air to clean it off, but we still need to remove the last little bits with some alcohol just to make sure. So it's now on, or it should be on. The light is on. and my mouse is moving. That is the important thing. Right, so with that sitting like that, this in position here, we want to fill the rest of this gap. We don't quite have enough material here, so what I probably will have to do is, oh, that's going to be a bit of a bodge really. I'll cut here and around through there, basically cut the base out and then keep this section. The base will look like that, but with a section of this cut into place. And once I've got the section of this out, I can trace it onto here, probably from the inside, and then cut them both to size. Right, as you can probably see, it's coming along quite well. I've fixed it all together and glued it using some what's it called, poly cement. This is ABS, so that will work. I've left some fairly large gaps though, so I've ordered some acetone and I've cut down some other bits of the grey plastic. I'm going to melt in acetone just to turn into a putty to create a filler to fill these in. I also probably need to fill in the feet because the shape of the sliding feet I'm going to use will probably be different. I may not even need to fill the feet, we'll see how it goes, but the main bits I need to fill are these cracks. I mean, not for any real need, just because it will look better. Right, I've attached the two main boards together by these flat routed solid core wires, so I've attached the negative to the negative and the positive to the positive, and I've also attached some test wires so that I can test it with a battery. So now I know this is working. I've bought these, which are essentially 1.5, well 1.2 volt AA's that I've tested and it works in here, but they can also be charged by an external USB, so that's really handy. So what I'm going to do is cut this off and attach this socket there as short as I possibly can, and then I can put the batteries in there. Actually, it'd probably be better laying them like that, and then I can stick the socket through the base somewhere like that. That should work fine, provided the batteries can lay down flat as low as possible out the way. That is where I'm having the problem with the fact I didn't remove the scroll wheel sensor or the left mouse click to the internal mouse. So what I'm going to do right now, I'd say that came off fairly cleanly, largely because it literally fell off. So the next bit is this. Now I've got to be very careful because there are surface mount components nearby. I will have to clean the board out afterwards, but I certainly don't want to hit anything else that I'm not aiming at. Yep, that'll do. If you have a look at this, you can see it fits mostly well, but because there are these gaps, I'm going to have to just fill them in. And what I've done is I've cut up some of the extra plastic that I've cut out of this hole into fine shards, and I'm going to melt it in epoxy. You'll see this in a later date. Right, we're back again. I have used the acetone and some of the offcuts of grey plastic to essentially create a filler to fill the gaps that I created. I've scraped off, while it was still a bit pliable, some of the inside so the circuit boards will still fit in there, but obviously for the outside that's not a great look, is it? So what I'm going to do is I've got some 180 sandpaper here, I've got some 400 here, and then these go from 1500 to 7000. I probably won't need to go that high. I think 3000 should be smooth enough to get a similar finish to this, but we'll see how it goes. But I'm just going to take very small sections and just try and focus on the bits there. I've taped off the bits I don't want to sand. There we go. I think I'll take that in half for now. Right, for this next bit, it's going to be a bit different. I've done the rest of the mouse, it's all put together, but I've skipped over all the soldering and the assembly, so because I was feeling a bit rough while I was doing it. So I think what I'll do is from here I'll show you what the mouse looks like in its finished form, and I'll do a teardown of it to show you how I did it and what I did. For a start, we've got you can see the integrated M325 into the M570. I've given it individual feet. You've got switches for both individual parts in case you don't want the underside running. They're both paired to a single unified receiver. You've got a charge port there that can plug the internal USB powered lithium ion batteries in. It's just a real pain in the backside to get the batteries in such a way that they are aligned correctly so that it will close. I mean, it does close properly, it's just tricky to get that to work perfectly. Right, these are probably going to need some more glue because I've opened and closed this so many times now that the glue is starting to weaken, but I'm sure that's something I can arrange, either double-sided tape or I can cut some new ones out of the foot material I bought a whole section of it and then just cut individual feet. Right, so I've got the rubber feet sitting under the other feet, and I've sliced them thinner so they can essentially act as mounts for the other feet. Otherwise you have these wells into the thing, and I could have filled those with ABS, but I didn't think about it at the time, and I don't think it's really worth it. I could also, if it was a real problem, fill it with epoxy putty and sand it flat, but again that just doesn't seem like it's much point when I can just use the feet that fit and are already there, and if anything they'll just provide a little bit of cushioning. Right, now I found that while taking this mouse apart, the easiest way to do it is to hold down on the ball and then lift the rest of the shell, because you want to keep that in place. So that is the top of the shell, and here's the internals. You can see two lithium ion AA 1.5 volt batteries. They both charge via USB, and I've extended the USB out from this adapter. I have checked that while they are charging, they still only put out 1.5 volts maximum, so you're not going to damage the board by charging it even if the board is still on, although I've deliberately put the charge port on the bottom so you can't try and use it while it's charging, because I don't want to make that risk. As you can see, each battery has one mouse. I did that because when I originally connected them, I must have done something to the M325 board, because it was working intermittently, and I wondered if that was because I had the two power rails connected. I think what eventually happened was because I'd flexed the board so many times when trying to get it into the space, I had cracked some of the solder joints. So when I reflowed all the solder joints and resoldered one of the capacitors, very tiny, it is now working perfectly. So I don't think that was the problem, but having two batteries in is not a problem anyway, because it does mean that you get a longer battery life. So this is sort of the maximum amount of battery life you can have. Now here I've put in a little extra, I'm not sure if you can see that on the camera, a little extra riser that is just slightly higher than the connector for that flat-flex ribbon cable, so that when the battery sits on it, it can curl the ribbon cable a bit, but it can never reach a stage where the cable is going to break internally. I can take the board for the M325 out. This is Blue Tech, and I'm just using it so that when this battery is seated with the other one sitting underneath it, it will close up correctly. Really, I could use anything, but Blue Tech just works, and it's non-flammable. The batteries are already wrapped in Kapton tape. So that is it. We've got the ball connected here. This is what provides all of the clicking and everything, and this is the M325 board, but is absolutely stripped down to literally just the necessities for detecting movement. I have got two little purple wires in there because I did find that I think that switch, when I removed it, was causing problems because I think it's bridging the ground plane through it. So what I've done is just put some wires in to keep the ground plane bridge. That might have been the problem, that when I flexed the board, that was the problem. But I thought I'd try that at the time, and there's no point removing it because it works just like the switch was there, so it's fine. And that's it. That is how the mouse works. Now I've just got to have the unenviable task of putting it back together. So here we are at my desktop. Here's the mouse. I'm not sure if you can see the cursor, but as I move the mouse, the cursor moves. As I move the ball, the cursor moves. With Logitech Setpoint installed, you can actually set them to move the mouse at different rates. Although I haven't got it installed on this PC at the moment because this is just for demo purposes. I'm not actually going to be playing things very much on here. So let's demo a game. Let's open up Steam and stream Duke Nukem 3D from my main computer. So that's all starting up. Here we go. Single player, new game, LA Meltdown, Hollywood Holocaust, whatever. This is just to demo that it works in the first place, although I have had problems with. Right, so where's to move? That moves, that moves. Now, for some reason in this game, that moves a heck of a lot faster than this does. But if you change the settings in Setpoint, then it works absolutely fine. So you can spin all the way around with that one and then do fine aim with the other one. Now obviously you would want the different mouse speeds set how you want them, and then the one in game will affect both mice. So if you find that they're both too slow, turn the one up in the game. If you find that one is too fast compared to the other one, you just turn that one up in the Logitech Setpoint. So it works. And I was using it the other day with, because I finished it day before yesterday, and I was using it yesterday. What game was it? Oh, that was it, Strafe. Strafe is a 90s style, but it's a new game that's 90s style, and it worked really well. Set up correctly on my other computer with the relative speed set correctly, I was using the ball to spin almost 360 and then the movement to fine aim. And that works quite well because instead of having to do this all the time where you lift the mouse to get enough space, you just spin the ball, and then when you're in the right direction you just move into the right to get the fine aim, and then when you're like too near the edge of the pad, well, you move the mouse back into the middle and compensate by spinning the ball. I mean, it works, it's fine. So that's the end of the project. Thank you so much for coming along with me. I hope you liked it. If you did, please leave a like below, it would be really helpful, or leave a comment telling me what you did like or what you'd like me to see me do next, and I hope to see you either in my next stream, same name on Twitch, or in my next project here. Thanks very much.